Alright, let's figure out how to get started in the screensaver program. And the first thing is, and you can again pause this if you want to take a look at it and make sure your code sculptor is set up, is that you want to create your code sculptor to have your basic imports, a blank draw section that we can draw in. Sometimes I put the pass in there to start, but then I erase it immediately when we actually start to work. Down here at the bottom, it needs to have the ability to have a frame that's 800 by 600. We're going to change that in just a second. Also a name, you could always call it something more exciting than home. One is what actually starts to get it to draw. This is an option. You could set the background color to something, but for right now I'm just going to keep my black background. We're going to do something cool with this later, and change it to something that makes the screensaver act really differently. So we will use this line later on, and then of course our frames start. So the first thing I want to do is this 800 by 600. We're going to change those. Instead of putting numbers down here, we're actually going to define them at the top of the screen. And I'm going to put these in all caps. When coders want to make something that they call a constant, which would be kind of the opposite of a variable, something that they don't want to change in their code, they'll call it a constant, and they indicate that by capitalizing. Does it have to be capitalized? No, it doesn't. That's a coder's what would you call that? Just standard practice that they say, okay, this is a variable, but I don't want it to ever change. For the whole program, I want it to be 800 by 600. So why do I bother? Well, it's because I'm going to want to refer to these numbers many times when I start to create my program. And so if I set them now, I don't have, and like, let's just say later I want to change it to, 400 by 300. I do it here, and it will automatically do it every single place I mention in my code. If I just keep it 800 by 600 and I change my mind later and want to make it a different resolution, I'd have to put it in, like make all sorts of changes in my code. So it's easier to do it once. And if I ever need to say what is the width of the screen, I can use width. If I say what is the height of the screen, I'll use height. Okay, so that being said, we want to draw a circle. So of course that's not how we draw a circle, is it? Canvas.draw circle. I started yawning again. I guess it's too late in the day. It's only block 4, but So we draw a circle, and we're not going to this time draw our circle with a number. We're going to draw our circle with a variable. So I'm going to call mine CX for circle X, and CY for circle Y. And sometimes I put dashes between them so that they're a little bit more readable, but I'm going to keep these short and just say CXCY. I need to know the radius of my circle. So again, I'm not going to say like 50 to get the radius at 50. I'm going to set it up ahead of time. I'm going to say CR for circle radius. The line thickness. Well, do I want the line thickness to be a variable, or do I want it to be something that's just always, 1 or whatever? So we're going to call this, let's just call it, CW for width. And then we're all the way at color. And we want our circle to have color, so let's go ahead and call it color. So I'm taking the circle and I'm kind of replacing everything we put numbers in, and I'm just going to make them variables now. Now the other thing that I'm going to do is I'm going to move that in a second, because there's things we want to do. So it's lots of times easier to make a function that can do things rather than drawing them. Well, you know what? Well, maybe I'll just leave it this way for now. There's different ways we could approach this. So one is we could put this whole thing in a new function and then do all the things to the circle in a function. But we're going to do it a little bit differently this time. So what we're going to do is set all these variables up here. So, what is my starting x value? Well, maybe I want it to start, I don't know, I could start it in the middle of the screen, which is why, again, we use our height and our width. If I didn't want to start in the middle screen, I could have just said, 0, start it in the corner of the screen. What is my radius? So what is my circle's radius. Let's just start it at 50. What is my width? I want it to be 1. What is my color? I want it to be white. So I'm just kind of taking the ideas here of like the formula for this circle and just making them all into variables, and then I'll be able to manipulate these variables later. So I should be able to run this code and realize that I forgot something. I put 2 parentheses there. I only needed 1. Okay. It's a circle. It's a circle without any color in it because really I want 2 colors, right? I want color, color. I'm going to make them the same. I'm not going to make them 2 different colors. I could do color 1 and color 2. But there we go. There's a circle on the screen. And if I told people in assignment 2, you might want to skip to do this one, and I'll explain everything on how to do some basic animations in this one. If you've done assignment 2, you've seen watched some videos probably, you kind of know what's coming. But what we can do is, if we're using CX and CY, and this is a loop that draws the circle over and over again, I can, increase their value. And because these values are increasing, we get an error. I did that on purpose, don't worry. But if these values are increasing and it's a loop, then where the location of the circle is going to change every time it runs through the loop. Now, why doesn't that work? It's because we're dealing with functions. Here we have some variables that we set up to work throughout the whole program. We would call those global variables. And we need to tell this this code, hey, these are all global variables, so they do exist outside of this program, so outside of this function, so you need to go look for them, which would be right up here. So I'm just going to list them all right there. Now it should work. So I got some basic movement. The center point of my circle is going to be moving, and it's gone. It moved until it got down here, and it just keeps on moving. It doesn't have any sort of idea that there's a limit to where it can go. It just thinks it's a number, right? The number just keeps going up and up and up, and this number keeps going up and up and up. So it doesn't know that there's a problem there. So then you start thinking to yourself, well, how can I tell it to not just go up all the time? Excuse me. I don't want it to just increase. I want it to sometimes decrease. Right? So what if I did like some sort of statement like, I don't know, like if the CX value is less than 400, maybe it would increase, and if it's anything else, like with greater than 400, then it would decrease. Would that do anything? And the answer is no, not really. I don't even know what it will do. Well, see, you can see it kind of wiggling as it goes down because I didn't change that on the Y value. It's right at 400 right now because it's the width divided by 2. And so it's like, okay, I'm less than 400. Okay, I'm greater than 400. And so it's just wiggling back and forth at one spot. It's not really changing direction. It is, but only 1 pixel at a time, which is not very interesting. So instead, what we need to do is we need to set like a variable for its direction, right? So what we're going to do instead is we're going to say we have a circle direction. I'm just going to abbreviate that for direction, right? And it's going to be equal to 1. I'll explain that 1 later. But now I can say not this if statement, but I can say CX is going to be plus equal to 1. No, to the C direction. And then I can say that now I can use if statements. So if my CX value ever gets greater than the width of the screen, I can change its direction. And the way I do that is I say take its direction and reverse it. So if it started at a 1, it now becomes a -1. And what happens when we add a -1? Well, it goes the other way. Right? But then it's going to get to 0. It's going to go, okay, now I'm negative, so I'm going to keep on going lower and lower and lower, and I'm going to get to 0, which is the left side of the screen. And I want to switch directions and start getting bigger and bigger and bigger again. So I can say, okay, well, if the CX gets less than 0, then I want it to reverse direction again. So this is a really handy way, just using one variable, and I can say, reverse direction. Now I didn't tell it to reverse direction on the y yet. And if you ever get those errors, it's because that's whole local variable thing we have to add. We're going to have to continually add things to that spot. So I told the x value to behave, but I didn't tell the y value to behave. So that doesn't do us a lot of good because it goes down the screen before it goes in the other direction. So I'm like, oh, well, I guess I need to do the same thing for cdir for the y. Now, if you think about this, the y and the x, because we're not in a square, we're in a rectangle, are going to be different. They're not always going to be the same. Sometimes it's going to hit the bottom, sometimes it's going to hit the left, sometimes it's going to hit the top. So I'm going to rename this one cxdir. And I have to do that in a few places. So I want to control the direction of my x value, and that means I have to bring it in as a global, and that means I have to say, okay, add my x direction to the x value of the circle, and I want to change that if I hit the edges. And then you can imagine, okay, if you have a value for your x, maybe you have a value for your y as well, and that's exactly what we do. I bring it in here on global, and then down here I say that if the cy gets greater than the height, oh, I forgot to change it to cydir right there, right? So cy plus equals cydir. And if it gets greater to the height, or it gets less than 0, then my cy direction needs to switch polar signs. And if I remembered all my things, so now I'm going to get a bouncing circle. And you'll notice it goes halfway off the screen. Remember that a circle is always based on its center point. And so I'm testing to see if the center is hitting. I'm not testing to see if the edges are hitting. And that, if that bothers you, good, it should. What you can do is you can say, if my cx plus my CR, what's CR? CR is the radius. So if the x value plus the radius is greater than the width, and the x value minus the radius is less than the width. So now I'm saying take a look at those edges and make sure that the edges aren't hitting. And you don't need to do this. This is kind of an option, but if you get bothered by the idea that those edges are getting hit, it's just that you have to remember, like, if you're testing the bottom of the screen, you have to say the cy plus the radius. If you're testing the top of the screen, you have to say the cy minus the radius to get the top of the ball. So it's kind of like you got 4 edges you got to worry about. This is really basic collision detection. We're seeing if the edges collide or the values intersect with the edges of the screen, and if they intersect, then we go ahead and move them. One more thing and we'll be done with this one, and that is this number right here. This number is how many pixels we add every time we want to change the x value or the y value. So if you want to go faster, you change that and you get a very fast ball. And if you want to go slower, you can. You can even go less than 1, which means it will take more than 1 cycle through the program before it makes it go to the next pixel. Right, this is now every 2 frames it will go 1 pixel, so it's like twice as slow. So you can change these around. And the other thing you'll notice, this is a quick math thing, is slope equals rise over run, or what do we say, like the b is the y divided by the x or something like that. If I have a 1 for 1, I've got a perfect, I'm going to go 5 for 5, I've got a perfect slope of a 45 degrees, so it's always perfectly diagonal because it's going the same amount up as it is over. But if I make these numbers uneven, now there's more more x change than there is y change. So I've changed the slope. And so now it's going to hit right? It's going more diagonal as it hits. It's not doing a perfect 90 degrees every time. And if you wanted to go more up and down, you would switch these around. And so they can be any numbers you can think of, right? Like, oh, I want to go 40 and I want to go 2 or something like that. And then you get crazy stuff like this. Now, if you make those numbers too high, the thing will go right off the screen because you can't like change things 400 at a time. There's only 600 pixels in a screen. So it's just like freaking out because it's trying to bounce and it can't. So that's, if you make those numbers go too high, they will kind of freak your computer out and it will stop working. So there's the basics of movement and how to keep things on the screen so you can bounce around. And we'll go over some other changes we can make to it in the next sessions.